In this video, I'd like to continue talking about factoring fourth degree polynomials using substitution. And we have this example problem where notice we have a fourth degree polynomial since that's the power of the highest power term. And this is a special case of a fourth degree polynomial where notice we are missing the x cubed term and we are missing the linear term, x to the first power. So when that's the case, we can notice that this looks very similar to a quadratic. In fact, if we rewrote x to the fourth as x squared squared, then it might be more obvious that this is really a type of quadratic expression. And what we'll do from here is use a method called u substitution, or just substitution. And we will set our variable, this new variable that we are creating, equal to x squared. And by doing this, we transform this fourth degree polynomial into u squared plus u minus 20. And this right here is a quadratic. And we can factor this using the techniques we've learned for factoring quadratics. So let me just make a little bit of room here. And we can factor this as a product of two binomials. Or we can at least attempt to do that. And if it doesn't work, then we can factor this using the quadratic formula. So with these two binomials, we know they each have two terms. And the first terms will multiply to give us u squared. So each of these have to be u, since the coefficient on u squared is just 1. If it was not 1, then we can try factoring by grouping. But since it is 1, we know each of these are u, since when we remultiply this out, u times u is u squared. And these terms right here, these will be constants, or just numbers, and they will have to multiply to negative 20, and they will add to the coefficient on u, which is just positive 1. So we need to think which numbers multiply to negative 20 and add to positive 1. So let's write out our list of factor pairs. We can multiply minus 1 and 20, or minus 20 and 1. We can do minus 2 and 10, or minus 10 and 2. We can do minus 4 and 5, or minus 5 and 4. And notice that when we add these two factor pairs together, minus 4 plus 5 is positive 1. So this looks to be the correct choice. And we can plug in minus 4 and positive 5 there. And remember, though, that we are factoring in terms of our variable x. So at this point, we need to go back and replace u with x squared, since we want this factorization in terms of x. So this equation here, this factored quadratic, we can rewrite it as x squared minus 4 multiplied by x squared plus 5. And of course, we can test this by re-multiplying everything out. So if we multiplied x squared into both of these terms and minus 4 into both of these terms, we will see that we get back the fourth degree polynomial that we started with. Though at this point, notice we can actually factor this a little bit further, since the first binomial, the one on the left here, this is really a difference of two squares. So let me write it a little bit more explicitly. This is x squared minus 2 squared. And we also know how to factor a difference of two squares. In fact, we could just use the method we used here to factor a quadratic, or we can remember that when we have a difference of two squares, let's say we have a squared minus b squared, that this factors to a minus b multiplied by a plus b, and this can be verified by just remultiplying this out. But essentially, when it's multiplied out, the middle terms cancel out, and you just get a squared minus b squared. So if we apply this formula here, then this first binomial here will become x minus 2. Notice that it becomes each of these terms, but now ignoring the squares, and you subtract them first, and then you add them second. And then this x squared plus 5, this is, in some sense, a sum of two squares, where you can really rewrite 5 as the square root of 5 squared, so that you can write it as something squared. And a sum of two squares, it is possible to factor that, but you need complex numbers to do so, and that's something we will talk about in a later video.